I'm Anil Kumar. Let me first thank my subscribers for active participation and sharing real good questions from their text. This one is from my student on vectors. The triple throw is one of the most difficult moves in pairs figure skating. Male partner throws his partner and adds his momentum to that of the female skater. She applies force with one skate to jump into the air. In order to make herself spin, let me correct this. Right? So, in order to make herself spin, she applies force at an angle to the initial direction and spins 3 times in the air before landing. Represent these forces and their resultant as vectors. So that's very interesting. So what we will consider here is we'll consider R3 vectors in 3 dimensions. Now let's take the skating of these partners on the floor. So what is happening here is that first let's analyze these statements. Male partner throws his partner and add his momentum to that of a female skater. So there's one force which is exerted by both these partners, right? Now, she applies a force with one skate to jump into the air. That is another force, jumping into the air. And then, in order to make herself spin, she applies force at an angle to the initial direction and spins 3 times in the air before landing. So what we have seen here is there are 3 forces, right? So basically, we're talking about 3 forces here. So let me just write down these 3 forces and then we will analyze them. So first one is both partners, right? And then we have from the female partner. Now these are in one plane, these 2 forces. The other one is the female partner jump, kind of, right? So this is kind of a, and then in order to spin herself, this is along the plane initial direction, right? And before that it says she applies force with one skate to jump into the air. So female partner to jump, right? So that is another force. So I could represent these forces kind of like this. Okay, so let's represent the forces. I'm just thinking about the ink, right? So what I will do here is I'll represent both partners. Let us say they are going in this direction, right? So that is the force exerted. Both are going together, right? So it's a triple throw, which is a pair skating, figure skating competition, right? So this is the first force. And then what happens here is that the female partner applies a force so that she can spin a bit, right? And this is at an angle. So that is the force which is being applied, right? So this is for spinning, right? Okay. The first force is when they add momentum to field. So male partner throws the partner and add his momentum. So add momentum. So this is the first force. So that will be actually longer. So let me just make it longer. Both apply this force. Let's assume this is longer. Okay. So we'll call this as the force exerted by both, right? Let's say this is A in vectors, and this one is by B, the female partner, at an angle. And let's say this angle is theta for us. Now these 2 forces are actually acting on the ground. So that is the plane. We call this as XY plane, right? So what I will do here is kind of okay, so what we'll do, we'll take resultant from here. So resultant of this is basically, you could make a parallelogram here, correct? So when you make a parallelogram, then you get the resultant, and resultant of this is that. So this force is A plus B. So that is the force of which adds to both, right? And then there is a third force which acts upwards, and this third force is for the jump, right? So this third force is for the jump, and that force helps for the female partner to be in the air and take 3 spins, right? So this force acts in, so this force is actually at right angles to the resultant and any of those two forces. It is kind of like this. Do you see that? So that's the scenario for us. So that is how you could represent all the 3 forces. So I have represented this force in green, the other force exerted by the female for the swing, the spin switch is taking place, and that is the jump, right? So these are the 3 colors which I have used. Now if you want to find the resultant of this, of course, you can add these two, this resultant with that, and get the resultant, right? So let me just make that resultant now. So it's kind of like this, right? So the resultant will be that the female will go like this in this direction, and during this time when she's in the air, right, she's in the air, she takes 3 spins and then lands perfectly to get a full score for that particular part of the skating, right? So that is how you could analyze it. Now you could also give some values to this, right? So to give values, what I will suggest is, let's consider the XYZ plane, right? So let me just make that XYZ plane. So in R3, we have XYZ plane kind of like this, right? That is my 3-dimensional view. Now on this plane, we can define these vectors and we can give them some values. So what I'll prefer is, this force going together, will put it along the y-axis. We'll put along the y-axis, right? So these are the 3 planes, X, Y, and Z. So we'll put this along the y-axis, and the force exerted by the female partner so that she could take spins while in air could be somewhere like this, right? So that could be the force, and as you can see, the resultant will be kind of, I should go parallel to this. So the resultant will be kind of like this, and the jump is a force which is upwards, correct? So in R3, we can designate the forces like this. Now at times, you can give some value also if you feel like. So approximately we'll give some values. We are taking this along the y direction. So let me call this force A. So I'll call this force A as equal to. So all the magnitude is along this direction. So let me give it a value. Let's say 80, right? So 80 newtons, right? And along x and y, it has 0, okay, component. Now let's take the other force, B. Now this force actually, let's say this was 80 newtons. This is, let's put this some value, okay? So let's this force be, let us say 50 newtons, okay? And let's give this as 10, okay? Let's say these are my 3 forces, right? Arbitrary values, okay? But anyway, important thing here is, if I know this angle is theta, in that case, I can say what B is. So the force B, whose magnitude is approximately this much, okay? So what we will do here is, it could be resolved into x and y directions. So in x direction, it will be sine theta of this, right? So you could resolve this into x and y direction. Theta is the angle which it makes with y-axis in this case, right? So cos theta component is with the y-axis, and minus this will be with sine, right? Do you see that? So the angle which we have taken theta is with the y-axis this time, right? So be careful about it. And what we notice here is that it could be written as the x component will be 550 sine theta. We'll put this minus looking into is going to that direction. The cos component will be 50 cos theta, and there's 0 component along the z-axis. And for the other force, let me call that to be C. C could be treated as 0, 0, and 10, as it is a jump which is upwards. Do you see that? So when you combine all this, then the net resultant, let me call that as capital R here. So the net resultant, which is basically kind of here in the air, which will be like this. could be written as, let me write down here, the net resultant is sum of all this. So let me write down R as equals to A plus B plus C, right? And that is equal to, okay. So as far as X components are concerned, okay, A is along the Y, I'm sorry. I should write 80 here and 0 there. Okay, 0 along the x-axis because I took X along, the first force along Y-axis. Okay, so it is, we can combine all this. So X component is basically minus, right, let me write here, minus 50 sine theta, right? The Y components is 80 plus 50 cos theta, and the Z component will be 10 as per the values which I took in this particular example, right? So I hope that helps you to understand a bit how these forces will act and what is going to be the resultant. So sometimes this kind of geometry helps you in taking values. Just you could write A1, A2, A3 also. I just took some values to make it more realistic kind of thing, right? Okay, I hope that helps. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to post questions. And let me again thank my subscribers for sharing this question. Thank you and all the best.